All right, let's dive right into this. Welcome to this explainer. Today, we are looking at something absolutely wild. The sudden, massive leap forward we're witnessing right now in humanoid robotics. You know, for decades, human-like robots have basically been locked away in research labs. They were strictly the stuff of science fiction or, dry academic papers. But practically overnight, they've exploded into the real world. We are literally in the middle of a humanoid explosion. So today, we're going to break down exactly what's real, what's just clever marketing hype, and what this all means for our very near future.
To start, we have to talk about the sheer scale of the financial expectations being set right now, because it is staggering. Tech giants are making these massive, world-changing predictions. Take Elon Musk, for example. He recently stated that Tesla's Optimus robot could be a product that brings in $30 trillion of revenue annually. $30 trillion. He's imagining a world where literally everyone on Earth has a robot. And honestly, it's kind of easy to buy into that hype when we look at the unbelievable physical feats we're suddenly seeing on our feeds every single day.
Picture this. Recently, developers took a humanoid robot called the Unitree G1, which, by the way, only weighs about 77 pounds, and they challenged it to pull a massive 3,100-pound car across a flat surface. And it actually did it! You can watch this lightweight little machine leaning back, rapidly adjusting its feet to maintain traction and autonomously balancing itself while hauling over 40 times its own weight. It's crazy! This proves that incredible dynamic physical balance isn't some far-off future promise. It is already here.
So, that brings us to the core mystery we really need to unpack today. Are we actually living in the age of the Jetsons, or is a lot of this just a mirage? Because right now, the market is this wild dichotomy. On one side, you have industrial robots pulling cars and doing standing backflips. But on the other hand, you have robots like Robotics Aria, which is this highly realistic conversational humanoid that can't even walk, but costs $175,000 and is designed basically just to keep you company and elevate a brand at a Vegas casino.
So here is our roadmap for today to help separate those flashy stunts from operational reality. 1. The humanoid explosion. 2. Solving the data gap. 3. The Wizard of Oz. 4. Robots in the factory. 5. Robots in the home. And finally, 6. The reality of 2026.
Let's get into Section 1, the humanoid explosion, from sci-fi to consumer product. Both China and the West are pushing these machines out of the lab at breakneck speed, and it's all fueled by this fierce global competition. It is a full-on gold rush, backed by billions in investments, and of course, the rise of really powerful AI chips. We are officially transitioning from proof-of-concept prototypes to actual consumer products. And there's one number that completely changes the game here. $16,000. That car-pulling, back-slipping Unitree G1 robot we talked about, it isn't some multi-million-dollar military project. It's a commercially available product that costs $16,000. That is less than a new compact car. The fall-in cost of advanced components like actuators, sensors, and AI processors is making this tech shockingly accessible.
But the really crucial point here is how massive the spectrum of the current market is. On the budget side, China's Nodix Robotics just launched the Boomi. It's a small humanoid designed for education and light tasks, and it goes for just $1,370. That's literally cheaper than a flagship smartphone. Then in the middle, we have the highly capable $16,000 Unitree G1, and way on the luxury end, we have the $175,000 companion robot Aria. So there is no single humanoid robot market right now. We're seeing entirely different ecosystems being built simultaneously. All right, Section 2, solving the data gap, the brains behind the brawn.
So, an agile robot body is completely useless without a smart brain to control it, right? Like, we've mastered the hardware to make a robot do a backflip, but teaching that same robot to look at a messy room, decide what needs to be cleaned, and physically execute the task without crushing a glass in its hand, that requires a completely different type of intelligence. Think of generative AI like ChatGPT as being book smart. It's read the whole internet, so it predicts text and images beautifully, but it has no idea what a coffee cup actually feels like. Physical AI, on the other hand, has to be street smart. It has to understand real-world forces, torque, friction, and gravity. Training ChatGPT just requires text, but training a robot to fold your laundry, that requires capturing complex 3D physics data that mostly doesn't even exist yet. We call this the robot data gap.
To bridge this gap, developers are getting incredibly creative. For instance, researchers in China recently unveiled a groundbreaking system called the WOW model. That stands for the World Omniscient World Model.
Instead of just passively watching videos, a robot powered by this model actually builds physical intuition through a continuous cycle. Step 1. It predicts what will happen if it moves an object. Step 2. It critiques and verifies the result. And Step 3. It refines its understanding of physics based on its mistakes. It's learning through trial and error, exactly like a human toddler does.
Moving on to Section 3, The Wizard of Oz, Pulling Back the Curtain.
Okay, it is time for a reality check. We need to pull back the curtain on those viral internet videos. Because while the hardware and AI are absolutely advancing, the way these robots are presented to the public can sometimes be a bit of an illusion. Whenever you see a robot doing some incredibly complex, delicate task on social media, you always have to ask yourself, are these robots actually thinking for themselves? And the answer, right now, is very often no. Just to give you an example, during a recent hands-on demo with a highly anticipated home robot called the 1X Neo, a journalist challenged it to simply load 3 items into a dishwasher. It took the robot 5 full minutes to do it. Why? Because it wasn't acting autonomously at all.
It was actually relying on teleoperation. This is when a human operator remotely controls a robot's movements, usually wearing a VR headset and using hand controllers. It's effectively a very expensive puppet. In fact, in a brilliant bit of irony, the human operator who was remotely piloting the 1X Neo during that demonstration was literally named Turing. You know, like the famous Turing test for AI? Now, to be fair, this isn't just to trick you. Teleoperation is actually a vital way companies gather that physical training data we just talked about, but it does mean true autonomy is still a work in progress.
Section 4, Robots in the Factory, the Real Proving Ground.
Before a humanoid is trusted to carefully fold laundry in your living room, it has to prove its worth and its safety on the assembly line. The industrial sector is the real proving ground for this tech, and here are the heavy hitters competing for factory floor dominance right now. You've got Tesla's Optimus, leveraging its massive auto manufacturing infrastructure to scale internally. Then there's Figuro 2, which is focusing heavily on dexterous hand manipulation and has already secured paid pilot programs with companies like BMW. And of course, you have the new all-electric Boston Dynamics Atlas, which has superhuman mobility and is currently transitioning from elite lab research into safe, repeatable factory work. Because here's the thing, on a factory floor, literally nobody cares if a robot can do a backflip. Here is what actually matters. They need full self-balancing so they don't fall over and crush something. They need end-to-end visual motor policies, which just means the robot can see a bin, understand what's inside, and physically pick it up. They need all-electric operation for quiet, clean movement. And, most importantly, they need multi-shift reliability and safety-rated collaboration. They have to work alongside humans safely for 8 hours straight without breaking down.
Let's look at Section 5, Robots in the Home, Companions and Housekeepers.
The ultimate dream here, the absolute holy grail of this industry, is taking these machines out of the factory and bringing them into our personal lives. And the approaches companies are taking to do this are incredibly diverse. They're focusing way less on heavy lifting and much more on safety, aesthetics, and social interaction. For example, the 1X Neo, which is projected to cost around $20,000, is lightweight, wears a cozy fabric sweater so it feels less intimidating, and is aimed squarely at physical household chores. Then you have the Realbotics Area at $175,000, which has hyper-realistic skin, makes eye contact, and is built purely for social companionship. And on the budget end, the $1,370 Boomy is targeting classrooms and kids' bedrooms for education. Now, as these robots start attempting chores in our homes, we are going to have to get used to a hilarious new concept that people are calling robotic slop. Think about it. If a robot puts away your clean dishes, but maybe puts the glasses in the wrong cabinet, or if it folds your laundry, but one sleeve is just awkwardly hanging out, well, it's imperfect. It's robotic slop. But honestly, it's still incredibly useful. We might eagerly accept a badly folded shirt if it means we got to sit on the couch and watch TV instead of doing it ourselves, right?
Finally, Section 6, The Reality of 2026. What happens next?
With all this rapid development, the hype is real, the investments are massive, and the capabilities we're seeing are astonishing. But projecting a realistic timeline requires looking past the marketing. For a humanoid robot to actually be a commercial success in 2026, companies have to clear some very strict operational hurdles. They need proven unit economics, meaning it has to actually be cheaper to operate the robot than to just hire a human. They need massively scalable data collection to train that physical AI. They will absolutely have to rely on human-in-the-loop teleoperation for safety in weird edge cases. And they need reliable unit hardware that doesn't just overheat or break down after an hour of use.
Which leaves us with one final, deeply personal question. To make a home robot smart enough to be truly useful, these companies will need your data. They'll need the robot's cameras mapping your house, watching how you do your chores, and learning your daily routines. So, are you ready to sign that social contract? Are you willing to trade the ultimate privacy of your inner sanctum in exchange for a machine that folds your laundry? The humanoid explosion is definitely here, and the tech is getting ready. But the real question is, are we? Thanks so much for joining me on this explainer, and I'll catch you on the next one.